Hello, everyone. Welcome back. Thank you for joining us, and good morning. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, Apple Valley, People's Republic of California.
And we are talking about some strange science today. So
We
buckle
are.
up.
What you're looking at here is an artist rendition of a giant planet. Well, they don't think it's a giant planet because it's too big, but it's too small to be a dwarf star. So maybe it's still coalescing and forming, but there's some chemistry analysis they picked up. Really, really fascinating. And this could help just help explain origins of Saturn, Uranus.
It's not only a
Jupiter.
dwarf, it's a brown dwarf.
Right. Well, exactly. A strange cosmic object nicknamed the Accident has given scientists their first glimpse of a rare silicon-based molecule long expected in the atmospheres of Jupiter, Saturn, and other giant planets. This faint, ancient brown dwarf, too small to be a star, too big to be a planet, was so unusual that only the James Webb Space Telescope could unravel its chemistry. Ooh. Against the odds, astronomers detect against the odds. They came from behind. Astronomers detected silane, silane, a molecule that had eluded every other search. Would you like to know more? I would.
Why has silicon, one of the most abundant elements in the universe, been so difficult to detect in the atmospheres of Jupiter, Saturn, and similar gas planets orbiting distant stars? A recent study drawing on data from NASA's James Webb Telescope or Space Telescope offers a new clue. The research centers on a strange object spotted by chance in 2020 and nicknamed the Accident.
Yeah, by chance, huh? The accident is what astronomers call a brown dwarf, a sphere of gas too small to ignite as a star, yet too large to be considered a planet. Even within this unusual category, it stands out. Its atmosphere shows an odd mix of traits, some typically found in young brown dwarfs and others usually associated with much older ones.
Because of this confusing blend, it evaded standard detection techniques until about 5 years ago, when a volunteer discovered it while combing through NASA data as part of Backyard Worlds, Planet Nine, which sounds like a TV show. This citizen science project allows participants worldwide to search for hidden objects using images from NASA's retired NEOWISE, Near Earth Object Wide Field Infrared Survey Explorer, which was operated by NASA's Jet Propulsion Laboratory in Southern California. So I wonder if that is at JPL. I wonder if that's where that is.
Oh, it's operated, but this is that NEOWISE is probably
Is
a
it satellite?
database. It's a database.
Oh, okay.
And it's cool that citizen scientists, you or me or whoever, can get into these archives and use an AI program and sift through all this. That's a fascinating, awesome.
Kids, classrooms.
Yeah,
Yeah,
could be
that's cool.
a class project.
Yeah.
Webb telescope spots the unexpected. The accident is so far and odd that researchers needed NASA's most powerful space observatory, Webb, to study its atmosphere. Among several surprises, they found evidence of a molecule they couldn't initially identify. It turned out to be a simple silicon molecule called silane, SiH4. So that's silicon hydrogen 4, not hydroxide, tetrahydride, I think. There we go.
Sure.
That's bothering you here.
Researchers have long expected but been unable to find silane not only in our solar system's gas giants, but also in thousands of atmospheres belonging to brown dwarfs and to the gas giants orbiting other stars. The accident is the first such object where this molecule has been identified.
Cool. Scientists are fairly confident that silicon exists in Jupiter and Saturn's atmospheres, but that it is hidden. Bound to oxygen, silicon forms oxides such as quartz that can seed clouds on hot gas giants, bearing a resemblance to dust storms on Earth. On cooler gas giants like Jupiter and Saturn, these types of clouds would sink far beneath lighter layers of water vapor and ammonia clouds, until any silicon-containing molecules are deep in the atmosphere, invisible even to the spacecraft that have studied those two planets up close.
Some researchers have also posited that lighter molecules of silicon, like silane, should be found higher up in these atmospheric layers, left behind like traces of flour on a baker's table. That such molecules haven't appeared anywhere except in a single peculiar brown dwarf suggests something about the chemistry occurring in these environments.
Okay, hold on a second. Go into the room. Get out of here. Quote, sometimes it's the extreme objects that help us understand what's happening in the average ones, said Faherty, a researcher at the American Museum of Natural History in New York City and the lead author on the new study.
Located about 50 light years from Earth, the accident likely formed 10 billion to 12 billion years ago, making it one of the oldest brown dwarfs ever discovered. The universe is about 14 billion years old, and at the time that the accident developed, the cosmos contained mostly hydrogen and helium, with traces of amounts of other elements, including silicon. Over eons, elements like carbon, nitrogen, and oxygen forged in the cores of stars, so planets and stars that formed more recently possess more of those elements.
Webb's observations of the accident confirm that silane can form in brown dwarf and planetary atmospheres. The fact that silane seems to be missing in other brown dwarfs and gas giant planets suggests that when oxygen is available, it bonds with silicon at such a high rate and so easily, virtually no silicon is left over to bond with hydrogen from silane.
So why is silane in the accident? The study authors surmised it is because far less oxygen was present in the universe when the accident brown dwarf formed, resulting in less oxygen in the atmosphere to gobble up all the silicon. The available silicon would have bonded with hydrogen instead, resulting in silane.
Quote, we weren't looking to solve a mystery about Jupiter and Saturn with these observations, said JPL's Peter Eisenhart, project scientist for the WISE, Wide Field Infrared Survey Explorer mission, which was later repurposed as NEO-WISE. Quote, a brown dwarf is a ball of gas like a star, but without an internal fusion reactor. It gets cooler and cooler with an atmosphere like that of gas giant planets. We wanted to see why this brown dwarf is so odd, but we weren't expecting silane. The universe continues to surprise us, end quote.
Brown dwarfs are often easier to study than gas giant exoplanets, except because the light from a faraway planet is typically drowned out by the stars it orbits. While brown dwarfs generally fly solo. So they're not in anybody's atmosphere. They're kind of just cruising around.
Right, because they're not a star and they haven't been caught in the gravity of a star yet. So that's why they're exoplanets. So maybe some of the planets in our solar system got caught by our sun. Maybe. I don't know.
Okay. And the lessons learned from these objects extend to all kinds of planets, including ones outside our solar system that might feature potential signs of habitability.
Quote, to be clear, we're not finding life on brown dwarfs, said Faherty, but at a high level, by studying all of this variety and complexity in planetary atmospheres, we're setting up the scientists who are one day going to have to do this kind of chemical analysis for rocky, potentially Earth-like planets. It might not specifically involve silicon, but they're going to get data that is complicated and confusing and doesn't fit their models, just like we are. They'll have to parse all those complexities if they want to answer those big questions. Hence using AI. You know what? I just had a thought while we were talking. You know what would be weird is if somebody on a way distant planet is looking at our sun and making a hypothesis about Jupiter, or Earth. That our planet is in the habitable zone. That would be hilarious. It'd be hilarious.
Yeah, like that planet looks like it could maintain life.
Well,
and here we are.
If there's an atmosphere,
Yeah. But yeah, maybe somewhere there's an AI model with Earth floating around on it, and they're thinking, we need to get there. We need to figure out if there's life on that planet.
Yeah.
I just hope the first life that they come to is not the squad. So
The squad.
the squad. Anyway, okay.
Thanks for joining us, folks. We'll catch you in the afternoon.
Take care, everyone. Thanks. All right.